The next two problems are graphing logarithms. In order to graph logarithms, what we attempted to do was first graph the exponential equation first. Let me back up just a step. We're going to isolate just on our basic log equation. Our basic log equation, the parent function would be log of base 2 of x before we do any transformations. And then this minus 1 is going to move it 1 unit to the right, and this plus 2 is going to move it 2 units up. So we know the transformation is going to make. But what we said we're going to do is we were going to transform this first into an exponential, and then get the ordered pairs of the exponential, reverse them to get our logarithm, which is the inverse, and then we'll make our modifications. So first thing I'm going to do is I'm going to find the inverse of this equation. So that means replace the x and the y's. So we switch places with those to find the inverses. I'm going to put a y there. Log base 2 of y. Then we solve it for y. To solve it for y, we simply rewrite it as an exponential. So that means this is the exponent I raised the base to. So 2 to the x equals y. Now this is the parent function I'm going to use to generate ordered pairs in this first chart over here. So this is going to be our exponential one. And if we put in a -1, 0, and 1, we can get our ordered pairs for that exponential. So 2 to the -1 is a half, 2 to the 0 is 1, and 2 to the first is 2. To find your inverse function, we have to reverse those. So in order to do the log ordered pairs, they must be the reversal of your exponential. So we're going to start off with 1/2, -1, 0, 1, whoop, reverse them, 1, 0, 2, 1. Okay. Now we want to take care of the transformations of that log graph. We said there are two transformations. This -1, since it's inside those grouping symbols, has to affect or change the x's. So instead of this being a half and 1 and 2, let's see if I can slide all those over. That'll buy me some room. So instead of that, we want to add 1 to all these. So if I add 1 to a half, now we have 1 1/2. And add 1 to 1, we get a 2. Add 1 to 2, we get a 3. So those are the x values of the ordered pairs. Now we want to add 2 to all the y's. So if I add 2 to a -1, we're at 1. Add 2 to 0, it's 2. And add 2 to 1, it's a 3. So these are the ordered pairs in green that I want to graph. So it's 1 1/2, 1. It's 2, 2. And it's 3, 3. Okay, so this is the path that we have from those three ordered pairs. We should remember that every log graph has a vertical asymptote. Now it is normally situated on the y-axis, but because we've moved the entire graph 1 unit to the right, then that horizontal asymptote gets moved 1 unit to the right as well. Well, struggling here a bit. Come on, line. There it is. Move it 1 unit to the right, and then you can finish your curve. So the curve is going to come down through the points that we have on our graph, come close to the horizontal asymptote, and then go on to the right forever.